What exactly is an electron? Imagine a tiny, invisible particle zipping around atoms at incredible speeds. That's what an electron is. It's a fundamental piece of the universe, smaller than anything you can see. Electrons are subatomic particles, meaning they are parts of atoms but are much smaller than protons or neutrons. They carry a negative electric charge, which is why they are attracted to positively charged particles like protons. In every atom, electrons orbit the nucleus, which is made up of protons and neutrons. The number of electrons and protons in an atom usually matches, making the atom electrically neutral. If they don't match, the atom becomes charged, turning into an ion. Electrons are special because they are elementary particles. This means they are not made of anything smaller. They have a very tiny mass, about 1/1836 the mass of a proton, and they behave both like particles and waves. This wave-particle duality is a key idea in quantum physics. Instead of moving in fixed paths, electrons exist in regions called orbitals, where there's a high chance of finding them. Each orbital can hold a specific number of electrons, and electrons have a property called spin, which is like a tiny internal angular momentum with two possible states. The way electrons are arranged around the nucleus determines how an atom behaves chemically. The electrons in the outermost shells, called valences electrons, are especially important because they participate in chemical reactions and bonding. This is why different elements react differently and why some metals conduct electricity so well. Their electrons can move freely, allowing electricity to flow. Electrons can also exist outside of atoms, free in space. They can be manipulated in devices like electron microscopes, which use electron beams to see tiny objects, or in cathode ray tubes, which were used in old televisions. Particle accelerators also speed up electrons to very high energies for scientific experiments. Understanding electrons helps explain many everyday phenomena. It shows us why materials conduct electricity, how chemical reactions happen, and how electronic devices like computers and smartphones work. They are tiny but mighty, playing a huge role in shaping our universe and our daily lives.